All right, well, let's go over the gas loss problems that you had. The first one, number one, it said about some pressure and stuff. So specifically, it said the pressure on 2.5 liters of anesthetic gas. All right, in other words, it's gas that you take if you're going to have surgery or anything done in your mouth. Changes from 105 kilopascals to 40.5 kilopascals. What will be the new volume if the temperature remains constant? So we have 2.5 liters, and that's at 105 kilopascals. Then it says that changes to 40.5 kilopascals, and we want to know what's the new volume. Temperature stays the same, so we don't have to worry about that. So I'm going to leave up here PV over T equals PV over T. So now when we look at this and go, okay, which one am I going to use? Well, I'm just using P and V is all, so I'm only using the top ones. So I'm going to have 105 times 2.5 equals 40.5 times V. I can leave T off because T stays the same. So I'm really using Boyle's law in this one. So when you multiply this, I got to divide both sides by 40.5. Whoops. Make that 0.5. So that lets me get rid of that, makes me V. And if you do the math on that, you're going to get 6.48. And what were we trying to find out? Volume, which was in liters. So 6.48 liters is the answer. All right. Okay, let's clear out this. And we'll go on to the next one. Oh, there goes my clock, my lights. So I'll have to go get my lights back on again. All right, second one. A gas with a volume of 4.00 liters at a pressure of 205 kilopascals is allowed to expand to a volume of 12 liters. What's the pressure in the container if the temperature remains constant? So we have a volume of 4.00 liters, and that's at 205 kilopascals. So kilopascals is pressure. Then it says it expands to 12.0 liters. We want to know what's the new pressure. And again, temperature stays constant again. So that means we get to leave temperature out of this. We're just using P and V on top. So I'm going to use 205 times the 4.00 equals, we want to find out what's the new pressure, that's my X, times 12.0. So we're going to get P by itself, so I'm going to take 12 and divide it on both sides. That lets me get rid of 12. And P ends up equaling, if you multiply this out, you get 68.3. And we were trying to find pressure, which is kPa, or kilopascals. So there's my answer for that one. Okay. And again, if we were to look at this and say, does this make sense? The volume went from really small to really big. It went from 4 out to 12. So if all of a sudden my balloon went really big, what should have happened to my pressure? The pressure should have gone down. So it went from 205 to 68. Okay, so it did go down. So that's good. All right, so let's go on to the next one. We'll erase all these. All right, next one says, if a sample of gas occupies 6.8 liters, so I got 6.80 liters at 325 degrees Celsius. Oh, that's temperature this time. What will be its volume at 25 degrees Celsius? Ooh, we're lowering the temperature a whole bunch. If the pressure does not change. So we want to find out what's the new volume. This time pressure doesn't change. So we're leaving pressure out of this. So we're going V over T equals V over T. But we got to change our temperature. Don't forget, we got to add 273 to this. So that's 8, 9, it's 598. And we're going to add 273 to this guy. So that's like 298. All right, so my volume, 6.80 liters over 598 equals X, which is our other V, over 298. So now I got to get X, well, I got to cross multiply. So I'm going to take this times that, this times that. So I get 598 times X equals 6.80 times 298. Then I get X by itself, divide both sides by 598. So that allows me to cross those guys out. And I get X equals 3.39. And what were we trying to find out? Liters. So it's liters. So now we were to look at this and go, does this make sense again? Well, my temperature went from really hot to cold. So if something gets cold in a balloon, what happens to the volume? What happens to the size of the balloon when you walk out of Myers? It shrinks. So it should have gotten smaller. So it went from 6.8 to 3. So yep, it did get smaller. All right, so it looks like we did that one right then. All right, we'll erase all this stuff. All right, so we're on to the fourth one. Exactly 5 liters of air. So we got 5.00 liters of air at, oops, is at negative 50 degrees Celsius. Negative 50 degrees Celsius. It's warmed up to 100 degrees Celsius, so it goes up to 100 degrees Celsius. What's the new volume? So we want to find out what's the new volume for this guy. So first thing we got to do is we got to take these temperatures and add 273 to it. Well, 273 plus a negative 50 actually means 223 Kelvin. And then add 273 to this guy is 373 Kelvin. So there's my two temperatures now. So again, we're getting rid of P, we're going to V over T. So we're going to have 5.00 over 223 equals X over 373. So we're going to cross multiply and solve, so we get 223 times X equals 5.00 times 373. We gotta get X by itself, so divide both sides by 223. That lets me get rid of that. X ends up equaling, if you do the math on this, you should have gotten 8.36, and we were trying to find volume, which is in liters, so we found liters. All right, we got one more. Let's look at this and see, does it make sense? We got a low temperature, and it got hotter. So if a balloon gets hotter, what's it supposed to do in regards to size? It gets hotter, it should get bigger. So we went from 5 liters to 8. Well, so it did, it got bigger. So that's what we wanted to know. All right, we'll erase this and we'll do the last one. All right, last one. A gas has a pressure of 6.58 kilopascals, so 6.58 kPa at 539 Kelvin. What will be the pressure at 211 Kelvin? So we want to find out what's the pressure in this one. Do I have to change my temperatures? Nope, I don't have to this time. They gave it to me in Kelvin this time. They didn't give it to me in Celsius, so I don't have to add 273 this time. So this time my volumes are staying the same, so we're going to leave volume out. So we're going to have 6.58 divided by 539 equals X over 211. So now we're going to cross multiply. So I'm going to get 539 times X equals 6.58 times 211. Divide by 539 on both sides. And X ends up equaling, we get 2.58, and we were looking for pressure, so that's kilopascals. So let's find out, does this make sense? My temperature went from really, really hot to cold. So as a container does going to change its volume, this is an aerosol can. If it gets cold, what's going to happen to the pressure? Well, the pressure should go down. So we started at 6.58, it became 2. Yep, so we went down, so looks like we did it right. All right, well, that concludes those problems. We'll see you next time. Have a great day.